Ecotourism is a wonderful way to get citizens involved and to have a vested interest in their environment. I know this firsthand. I started scuba diving off the coast of California 6 years ago, and it quickly became my passion. I met a great group of like-minded people, and every weekend, weather and water quality permitting, we head into the Kelp Forest off our coast to see what the ocean has to offer. In today's demonstration, I will show you how to perform a site suitability analysis. We are citing the location for an ecotourism group to go diving, but you can apply the techniques and methods to whatever it is you would like to find the best location for. Let's go ahead and look at the data we will be using. Our study area is here in California, right off the coast, in the area surrounding the Channel Islands. I have several data sets that will help us model the different criteria in our site suitability analysis. First, we have the coastlines. The coastlines will primarily be used as barriers to restrict our analysis to only take place within the oceans. Next, I have the marinas in the study area. There are 3 of them. Our ecotourism dive boat will need to leave from one of these marinas. The closer a dive site is to a marina, the more economical and accessible it is. This is what I think is the most important layer or criteria in our model, and that's the Kelp Forest. The Kelp Forest is where we want to dive. It is a special attraction off of our coast. The kelp layer is derived from a multispectral image and is represented both the exposed and submerged kelp. My preference is always to dive in the marine protected areas. There are various levels of designation. Some locations are no access, others are restricted from fishing, and some are zoned for multi-use. I prefer diving within the fully protected areas. I think it is safer for divers in areas where fishing is not permitted. There are fewer ghost lines to get caught in, there are usually fewer boats overhead, and the wildlife is often richer. Next, we have Seki Depth. This is the depth that measures vertical visibility from the top of the water down. This layer will be used as a proxy for horizontal visibility. I also have the boat density traffic layer. It is not safe for divers to be on the surface with heavy boat traffic. Therefore, we want to avoid high density areas. And finally, we have the bathymetry data. Recreational divers have very strict depth limits. The initial certification allows scuba divers to dive to a depth of 60 feet. An additional certification allows divers to dive to 130 feet. Therefore, we do not want to include any areas deeper than 130 feet for this analysis, as we are citing dive locations for recreational divers. Now let's circle back to a couple of the criteria I spoke about. I mentioned that it was the distance to marinas that was important for convenience and cost, but I don't have the distance to marinas. All I have are the marinas themselves. Now let's go ahead and calculate the distance to the marinas. To do this, I will use the distance accumulation tool. It's in the Spatial Analyst toolset in the Distance toolset. It is a new tool introduced in ArcGIS Pro 2.5. Our input will be the marinas. We can specify a meaningful output name. And our barriers will be the coastlines, so that we only get distances within the ocean. Once I run this tool and I add the result to the display, we can see that a layer is created and every pixel now has a value that represents the distance to the closest marina. I had to run the same tool using kelp as input. So now I have a layer that represents every location within my study area and how close it is to the closest kelp bed. Now that we have derived all of our data, let's move on to the next step, building our suitability surface. We cannot build a suitability surface by merely combining the data sets the way they are. For example, adding bathymetry data to Seki Depth to boat density does not give us a meaningful result. We need to take this continuous data and put it onto a common scale. We are going to build the suitability surface in Model Builder. Probably some of you, but maybe not all of you, have worked within Model Builder before. Model Builder is a great tool to use to perform your analysis. It allows you to easily modify your analysis, to share it with others, and to explain it to colleagues. In the interest of time, I have already built our model, and it is open here in an edit session. You can see all of the blue ovals represent the input data we just went over: bathymetry, Seki depth, boating density, etc. All of the yellow rectangles represent the geoprocessing tools. Down here you see the distance accumulation tool. And the green ovals represent the results from the geoprocessing tool, such as distance from marinas. Now we need to put the data on a common scale so that we can combine them in a meaningful way. I have picked a scale of 1 to 10 that I will use to represent suitability throughout this analysis. 1 will represent the least suitable locations, while 10 will represent the most suitable locations. You can pick any scale you want, for example 0 to 1 or 1 to 100, and so on and so forth. The only thing you must be mindful of is that you use this same scale in the same way across all of your criteria throughout your analysis. I have two different types of data. I have continuous data, like depth, distance, and density, but I also have discrete or categorical data, such as the protected areas. First, let's look at how I'm going to reclassify the categorical data. To do this, I will use the Reclassify tool found in the Reclass toolset within Spatial Analyst. It's right here. So I already have it added to my model with marine protected areas as the input. Then I get to pick the field that I would like to reclassify. In this case, I've selected the protection level field, and the values from that field are populated here. Then on the right of this table, I get to assign the new values, the suitability values, on my scale of 1 to 10. You can see I have 10, the highly suitable areas, as the no-take areas, because I believe those are the best areas for diving. And I have other values as well. I don't have all of the values, and that's okay. I just have to keep in mind that 1 is the least suitable, 10 is the most suitable. Areas on this data set that are no data are areas that are not protected, but you can still dive in them, so I gave those a 5. Areas that are no access, even for scuba divers, I'm going to exclude from my analysis altogether, and I've reclassified those values to no data, so they will not come up on my suitability surface. Once I run that tool and I add it to the display, you can see that I have those same values I assigned to the different types of protected areas. I have the value of 5 for areas that are not protected at all, and I have the value of 10 for the areas that are protected in no-take areas. Next, let's see how we should reclassify the continuous data. There's another tool in the Reclass toolset called Rescale by Function, and I have added it to my model here several times. Let's take a look at the Rescale by Function tool with bathymetry data as input. The first thing I get to do is pick a transformation scale. I have picked MS large. The larger values, or the shallower values in this case, are more desirable for my divers. More people can dive there, there's more light. There's all kinds of reasons why we might rather dive in shallower. You get a longer dive, but there's an absolute threshold for recreational divers, and that's what we're modeling. So that's minus 130 feet in depth. So anything deeper than that, I've given no data, as it is not a viable dive site in this scenario. And then I use that same scale of 1 to 10. Once I've run that tool and we take a look at the output, we can see that this is the rescale bathymetry data. The values of 10, which are the most suitable locations, are here in green, and the areas that are not suitable or less suitable are here in red. And areas that are deeper than 130 feet, which are not acceptable for dive sites in this analysis, have been given no data. The reason I use rescale by function is so that the data remains continuous, and I get to maintain the high level of granularity. I don't want to use my continuous data and reclassify in this case, as it would bin the continuous data into discrete categories. Next, we need to combine these reclassified and rescaled rasters, and we can do that now that they're on a common scale. To do this, we will use the weighted sum tool. This tool is found in the overlay tool set right here, and I've added it to my model. This tool does not only combine data, but it also weights the data in importance to the other criteria. For example, I think kelp is the most important criteria. I gave it a weight of 2. Therefore, I'm saying it is twice as important as boat density that has a weight of 1 or bathymetry that has a weight of 1. With weighting it, I can combine it, I run this tool, and I add this result to the display. And it looks like this. Now this is my final suitability raster. It has all the different locations that are suitable for diving. There's kelp there, it's in a fairly shallow depth, there's not a lot of boat traffic, all those criteria are taken into consideration, weighted, and combined. So anywhere that is dark green is a highly suitable location, and anywhere that is red or orange is not very suitable, and anywhere that is no data is just not an acceptable location. With that, I'm not done. The dive boat doesn't know now where to go diving, it just knows where's better and where's worse. So there's one more tool I'd like to show you, and that's called the Locate Regions tool. This tool is also in the overlay tool set, and I've added it to my model. There are many parameters here. We'll go over just a few of them. The input is that suitability raster I just created. I get to pick a total area. I pick 30 square kilometers. But here you can see I get to pick a number of regions. And for this analysis, I've picked 3 regions. I went 3 separate dive sites because that's often how many dives a dive boat does in a day. But I want a minimum distance between them. I don't want them all touching each other. It won't seem like they're different dive sites. They won't be diverse enough. So I said I want at least 5 kilometers between the dive sites, but no more than 20 kilometers between the dive sites because the boat needs to be able to travel to each of these dive sites in a relatively short amount of time. So once I've done that, and I've run the tool and the result gets added to the display, you can see I have 3 separate dive sites located here around Santa Rosa Island and the Santa Cruz Island. If I go ahead and add the suitability layer underneath that, and if I use the swipe tool, then you can see that those areas show up underneath some of those dark green locations. I know that getting citizens involved in their environment, getting people to enjoy the ocean in a very intimate way can help motivate people to protect and restore the oceans. I know this because I've seen it happen to myself. When I started diving, dive sites were full of starfish. Now there's almost none. I have seen locations become urchin barrens, losing their kelp forests almost entirely. I've seen the invasive algae, sargassum, take over our rocky reefs. Seeing this, realizing what is at stake motivated me to become a citizen scientist and join an organization called Reef Check. Now, several times a year, I go diving, not merely for recreation, but I go with a team of trained citizen scientists. We monitor the health of the rocky reefs, where the kelp forests grow. We survey these sites by laying transect lines and counting the fish, the algae, and the invertebrates. The results are used to improve and manage these critically important natural resources. Reef Check programs provide ecologically sound and economically sustainable solutions to save reefs by creating partnerships among community volunteers such as myself, government agencies such as some of you, businesses, universities, and nonprofits. I strongly believe that getting citizens involved in ecotourism can help preserve and save our oceans.